kids, here we go. 611. All right. It's a little lesson over how to find arc length and area of a sector. Okay, arc length is a portion of the circumference, and area of the sector would be something like this, area of that sector. Okay, so first arc length. Arc length. All right, well, we need to know how many degrees that central angle is. So we're going to have x degrees compared to 360. All right, and that is equal to, times the entire circumference will equal your arc length. All right, so in other words, we're taking a fraction of the circumference. That's what this is, a fraction. Okay, so from this we have unknown. The r in here would be unknown. And, well, variable, I should say. X is a variable, our angle there. Our radius is a variable, and our length is a variable. So we can give you any one of those items, and you should be able to solve for the third. All right, so let's take a look at a couple problems here. All right, and you should have your copy out in front of you as you do this, or online, up on the screen, maybe up in a corner. All right, in case there's something here you can't read, but hopefully you can read it all. All right, got a circle. We have a x angle of 45 degrees. Our radius is 3 centimeters. Okay, so the circumference of a circle is 2 pi r. All right, so the circumference of this circle is 2 times pi times 3, or 6 pi. By the way, they say exact answer, so I know I'm going to keep pi in my answer. I won't have to pick up my calculator to figure out what 6 times 3.141659 blah blah is. Okay, so now length of AB equals 45 over 360 times the whole circumference, 6 pi. All right, now I happen to know that 45 over 60 is 1/8 because I've done this many times today. 1/8 times 6 pi is equal to 3/4 pi. All right, there you go. Next one. Okay, on this one they give us a diameter. Okay, we need the radius, so half of that 14 meters is 7 meters. By the way, this one back here was in centimeters. Okay, now, all right, we have 80 degrees. So again, we're going to set it up. Arc AB is equal to the fraction of the circle, 80 over 360. Times circumference, which is 2 times pi times 7. All right, and now we just simplify. We leave it in terms of pi. And let's see, that's 560 times 2 over 360. All right, yes, I should get my calculator. But let's do that. 56 times 2. Okay, we can do that. That's 18. Okay, so I've gotten it down to 56 over 18 pi. And I can divide both by 2, so 26 over 9 pi. And I don't believe 26 over 9 will reduce anymore. So, assuming I have done all that math correctly, which everything looks good. All right, there you go. And it is in meters. Okay, example 2. Just kind of I'm going to look at how this thing builds out if you have concentric circles. All right, we have integer radii, that means whole number radii. For each value of the radius r, find the corresponding arc length. Okay, now we have a radius of the first circle of 1. Notice that one is not drawn on here because the smallest circle here, radius, is 2. But we're going to do this, so the exact arc length here for a 60-degree angle, and if you'll, 60 out of 360 is 1/6. Okay, 60 out of 360 equals 1 out of 6. All right, so that's the thing you're going to see me using up here. All right, and I'm going to do one for this picture, for this circle that is not pictured first. Exact arc length will be 1/2, or sorry, 1/6, times 2 pi, and then times 1, but we don't need that to show that, so 1/3 pi. All right, so the next one, I know I'm going to have 1/6 times 2 pi times 2, so that's 4/6 pi, which is equal to 2/3 pi. 1/3, 2/3, interesting. Let's do one more and see if this pattern keeps. I'm going to switch my work to down here. So 1/6 times 2 pi times 3, oops, and there we have it, 6/6 pi, which would reduce to 3/3, but it is also just pi. All right, so, but we've got 1/3, 2/3, 3/3, so I believe I can say that this is 4/3 pi, 5/3 pi, 6/3, or 2 pi. This one is 7/3 pi. All right, approximate arc length, L to the nearest tenth. All right, so here you're just going to multiply each time times pi, so you can do that yourself. Now, when we graph it, we're going to find that it's going to go here, here slightly above. You're going to have a 2.1 there. You're going to have a 2.1, 3.1, then it goes to 4.2, 4.2, and 5.2, 6.3, 7.3. What kind of relationship are you seeing there in that line? Okay, literally in that line, I just said it. It's a line, so therefore it is a linear relationship. When you're dealing with concentric circles, again, with a distance of 1 between each of them. All right, it also is going to relate to the scale factor. All right, so let's look at next page. Where's my extra copies? Here we go. Okay. Oops, I'm sorry. What did I do here? There we go. Okay, what happens to the arc length when you double the radius? Okay. The arc length increased by 1/3. By 1/3. All right. And actually, how does it relate to the idea that all circles are similar? If we look back here at this original picture, I can see a 1 out of 3 right here. All right, and so 1 from there to there over the whole thing, from there to there, which is now 1, 2, 3, 4, sorry. Yeah. It's related to the scale factor. Okay, but each time it is increased by 1/3. How is it related to all things are similar? Each time the increase is the same. Increase, or in other words, is proportionally the same. the same. Okay. So now, area of a sector. All right, this was the second thing we're doing in this section. So we have the whole pie. I always think of area of a sector as how much of the pizza is somebody going to get. All right, so again, you need to know that angle. That tells us how much of the pizza we're getting, what portion. And now we want to know how much are we actually going to eat. Okay, so we would again take that x degrees over 360 and we would multiply it by the area of the whole circle. Okay, and the area of a whole circle, I'm going to expand that out. The area of a circle is equal to pi times r squared. All right, and then we have units squared. All right, so sector area. Let's take a look at this problem, example 2. All right, so we now have area of a sector equals 36 over 360 times pi times 5, that's the radius, squared. Okay, it wants exact answers and approximate answer to the nearest hundredths. All right, so we have right here 36 over 360 is 1/10. 1/10 times 25 times pi, which equals 5 over 2 pi. All right, and you can figure out what that approximate answer is. I don't have my calculator with me. All right, so right here, 65 degrees, again, area. Oops, but look, area of the sector is that other piece. All right, so first thing I'm going to do is 360 minus 65. So that's 295 degrees. And that out of 360. Could I have done my subtraction at the end? Absolutely. All right, but I'm going to choose to do it at the beginning. Area of the sector, because this is going to be a big piece of this pizza. All right, 295 out of 360 times pi times 11 squared. All right, further reducing, it's 295 out of 360 times 121 pi. Oh, 295. How many nickels in $3? 20, 40, 60, that's 59. And nickels in $3.60, that's 20. And 15, 30. No, wait, okay. 295 divided by 5. 5, 45, 59, got that right. 360, 5 is 7, 35, 72. 72 pi. All right, so then you can do your thing. Did I do that right? No, I sure didn't. I'm not done. I've done it right so far. 59 over 72 pi times 121. All right, so take the 121 times 59. 59 over 72 pi. All right, whatever that number is, that should be your exact answer. And don't forget that we have square inches here. All right, so you can do exact answer with that, and then you can do the approximate answer in your calculator. What information do you need to find the area of the sector? I think you need to know how big the piece of pie is. Let's go back. What happened here? Okay, it should still be filming. You need to know the angle measure of your sector.